Perhaps you have watched a modern survival reality show. It often features a host grimacing as they try to swallow a plump larva, immediately followed by a detailed explanation of how many calories it provides and how many grams of protein it contains. The modern obsession with quantifying energy into numbers has turned the process of survival into an entertaining equation. But for our Homo sapiens ancestors, an earthworm was not a protein math problem. It was the absolute line between life and death. When turning the clock back to the Pleistocene era, early Homo sapiens faced the same biological mandate: consume enough energy. But they had no concept of calories, no laboratories to analyze micronutrients. Energy for them was not a number printed on a package. It was a direct and brutal sensation felt in their muscles and nervous system after every meal. Hunger was an alarm signal, and the feeling of fullness was a reprieve from a death sentence. Instead of reading a nutritional label, the evolution of Homo sapiens relied on reading nature's signals through a series of bloody survival memories. Experience was humanity's first nutritional label. It was distilled from immediate consequences. Eating a particular root provided enough strength to travel for another day. Conversely, taking a bite of an unfamiliar, brightly colored berry could lead to violent stomach cramps, vomiting, or death right before the eyes of other members. This continuous process of trial and error, passed down orally through generations, was the primitive human's database of food sources. Food, in the context of ancient survival, was completely stripped of the concept of taste. It was a pure strategy. The prehistoric diet was not a choice, but an obligation. The ability to distinguish what kept one full, what appeared after the rains, and which animals carried dangerous pathogens was the boundary that defined which branches of human evolution would continue to exist, and which would be forever buried beneath geological strata. The development of the human species was shaped by those decisions. Those decisions, they didn't take place in a laboratory or a nutrition classroom. They were made on wind-swept savannas, in humid, dense forests, and under the blazing African sun. Popular culture often paints a distorted picture. It envisions the great warriors of human evolutionary history, spears in hand, joining forces to take down giant mammoths. That picture, while heroic, unintentionally creates a prejudice. It diminishes behaviors like digging for tubers, gathering fallen fruit, foraging for worms, or catching insects. It views these acts as signs of extreme hunger, of wretchedness. This perspective runs completely counter to basic ecological principles. In a volatile, natural world, being a picky eater or relying on a cold source of nutrition is a deadly luxury. Specialization is the shortest path to extinction. An apex predator that hunts only one type of prey will immediately face the brink of annihilation if disease or climate change wipes out that prey population. They have no plan B. Homo sapiens did. Our ancestors possessed a biological weapon more powerful than any set of claws or fangs. It was a digestive system and a brain that allowed them to become the greatest omnivores of all. They were not bound to any fixed source of life. The prehistoric diet was a list spanning every corner of the ecosystem. It was fatty marrow, cracked from carcasses left behind by larger predators. It was animal fat, a precious source of concentrated calories. It was small animals that unfortunately fell into traps. It was fish trapped in shallow pools when the tide receded. It was bird eggs stolen from nests high above. It was reptiles hiding in rock crevices. It was protein-rich insects and larvae. It was rare, sweet honey. It was wild fruits, hard nuts, tubers buried deep underground, and even freshly sprouted shoots. Each of these foods represented a piece of the energy puzzle. They were ready to compensate for one another when the surrounding environment changed. This was not desperation. This was strategy. The dietary flexibility of primitive humans was an active coping mechanism for the extreme instability of the Ice Age. When a prolonged drought forced large herds to migrate to other lands, Homo sapiens did not sit and wait to starve. They bowed their heads to the ground, foraging through leaf litter for larvae. They waded into shallow streams to catch crabs and snails. They used sticks to dig deep into the clay to find starchy tubers. Being omnivorous did not make them inferior. On the contrary, it proved the superiority of their adaptability. It helped them squeeze through the narrow gates of survival that so many other species, including our own close relatives, could not pass. Human development was built on the very foundation of not refusing anything that nature offered or left behind. That foundation allowed them to survive and then to begin a new journey, leaving their African homeland to face even harsher challenges. Ancient cave murals always celebrate the dramatic moments of the hunt. They depict large beasts cornered, sharp spears piercing flesh. These are stories of courage, of triumph. But they do not tell the whole truth. They do not record the long days of returning empty-handed, the infected wounds from a goring, or the silence of the tribe when a hunt failed. Biological and archaeological evidence point to a different, less glamorous, but far more decisive picture. In those days, the life of the group did not depend on the red meat they failed to secure. It relied entirely on the quiet, patient, and consistent existence of the plant kingdom. It was the wild berries, an instant explosion of sugar for exhausted bodies. It was the nuts, dense reserves of fat and protein. It was the tubers and roots, hiding complex carbohydrates right beneath their feet, along with stems and tender leaves. Unlike prey that always tries to flee or fight back fiercely, plants remain stationary. But that stillness is a trap. To harvest them, Homo sapiens required a system of environmental knowledge as deep and complex as any hunting tactic. A mistake did not lead to a scar, it led to death. To survive, they had to be instinctive botanists. They had to memorize a vast amount of information, precisely distinguishing each type of leaf, for a single confusion between an edible plant and one containing lethal toxins meant that a stomach cramp would be their final lesson. They had to know which fruits were only safe when their skin turned dark red. They had to understand which tubers needed to be dug half a meter deep during the dry months when the ground turned as hard as stone. They had to learn how to use stones to crush the hard shells of nuts to remove toxins before their stomachs could process them. This was not abstract knowledge. This was humanity's first nutritional chart, written in the consequences of life and death. A downed deer could provide a calorie-explosive feast for the group for a day or two. But a thorough understanding of the distribution maps of tubers and the seasons of ripening fruits was the safety net that extended the life of the tribe for weeks and months. The memory of plants was an invisible encyclopedia. It helped Homo sapiens overcome harsh winters and devastating droughts when the best hunters had to bow before the silence of the savannah. But the history of human evolution was not written solely by blood-stained spears. It was also written by calloused fingers, diligently digging and overturning stone after stone. Epic tales rarely celebrate the image of someone patiently picking grubs out of a rotting log or setting a trap for a field mouse. These acts lack grandeur, they lack drama. Yet, in the harsh reality of the ancient struggle for survival, these food sources, small and unglamorous, served as an underlying energy current, filling the lethal gaps between grand hunts that could fail at any moment. From a scientific perspective, insects, larvae, bird eggs, small fish, crabs, snails, and reptiles are highly efficient energy capsules. They are sources of pure protein for muscle regeneration after a long day of travel, and essential fatty acids to continue nourishing the complex brain that shaped human development. A handful of plump larvae found in a damp log after the rain provides immediate calories with almost no physical exertion required by the gatherer. More importantly, they carry no risk of being impaled by a sharp horn. Modern humans measure them in grams and numbers. Our ancestors measured them in one more day of life. Exploiting these small food sources was also a master survival strategy in terms of social organization. It allowed every member of the group to participate in the foraging machine, regardless of physical condition. While the strongest, healthiest adult males could risk days tracking large herds, life at the campsite never stood still. Older children learned to turn over stones to find scorpions, distinguishing between those that were edible and those that carried deadly venom. Women, even while pregnant or caring for infants, could collect shellfish along stream banks. The elderly, with a lifetime of accumulated experience, knew exactly which tree roots or rock crevices held bird nests. Even injured hunters recovering their strength could contribute by setting traps for rabbits and small rodents around the cave. Thus, the tribe's calorie-gathering machine operated without a moment's rest. Therefore, eating insects or digging for larvae was not a symbol of desperation or a dead end. It was an incredibly wise calculation of energy costs, a core legacy in the evolution of Homo sapiens. A larva does not bring the glory of defeating a mammoth, but in the leanest seasons, when great hunts failed and hunger loomed, that very larva was history preserved. It was protein. It was life. It was the affirmation that to survive and conquer the world, sometimes the most important thing is knowing how to bend down. And bowing down is not the only option. Sometimes, to survive, they have to look up, look out. The development of humanity did not take place on a flat stage. The life of early Homo sapiens was not imprisoned within a monotonous plane. It was a symphony of relentless movement along complex topographic axes, from low-lying marshy areas through gently sloping hillsides and sometimes reaching up to high rocky mountain ranges. Each meter of change in elevation is a comprehensive change in the menu, in temperature, and in the level of danger. In low-lying areas, such as deltas, along rivers and lakes, or in swamps, resources seem endless. Fish swim in shoals. Waterfowl eggs lie scattered about. Aquatic plant stems are rich in starch. And most importantly, the opportunity to access the carcasses of large animals that come to drink water and collapse. This is a promise, an abundant feast. But the price to pay for this richness is an extreme level of risk. This is the territory of giant crocodiles, of dense packs of predators lying in wait. Danger does not come only from sharp teeth. An invisible but deadly threat from parasites and diseases in the wet, stagnant environment is always present. A small cut can lead to infection and death. A wrong gulp of water can be a death sentence. Therefore, they moved higher. Mid-altitude, hilly terrain created an ideal ecotone. This was the balance point of ancient survival. Here, the primitive human's food source was still relatively abundant. Wild fruits, seeds, tubers, and small animals were everywhere. More importantly, the terrain provided natural rock shelters or caves. These were perfect refuges, shielding them from wind, rain, and nocturnal predators. This mid-altitude zone also offered an invaluable strategic advantage: vision. From above, they could observe the movement of large herds in the valley below, plan a hunt, or detect threats from afar. High-quality stone deposits for tool-making were also common here. It was a perfect balance between calorie acquisition and life preservation. But the world is not always ideal. Sometimes pressure from enemies or the depletion of resources forced them to climb even higher. As they ascended to higher regions, the battle for survival became harsher than ever. The air grew thin. The cold at night was bone-chilling. The calories expended for every uphill step were enormous, while food sources grew sparse. Every root found, every small animal caught, had to be paid for with precious energy. Where does the decision lie? Stay in the risky lowlands for a full meal that might be the last one? Reside on the safer hillside, even with limited resources? Or take the risk of climbing higher to escape enemies, facing hunger and cold? This is not a philosophical choice. This is a survival puzzle calculated daily, hourly. For the prehistoric diet, altitude is not just mindless contour lines on a map. It is the life or death menu of that day. Experience is the first nutritional chart in the history of human evolution. The process of consuming food is not merely a matter of fueling a machine. When viewed through the lens of tens of thousands of years, it is a relentless biological pressure. The nature of the food source, its hardness, chemical structure, and stability has participated directly in reshaping the anatomy of those who consume it. In the early stages, when the prehistoric diet depended heavily on tough plants and raw meat, the body was forced to adapt. Imagine crushing fibrous roots or tearing through the persistent tendons of a freshly hunted animal. It required a tremendous biting force, a repetitive movement that drained energy and eroded tooth enamel. This constant mechanical pressure created a massive chewing apparatus. Jaw muscles became exceptionally muscular, cheekbones widened to provide leverage, and molars grew to a massive size with thick enamel surfaces. The faces of these ancient ancestors bore a heavy, rugged appearance. It was the mark of an uncompromising struggle for every bite. But then a turning point occurred. As Homo sapiens became increasingly flexible in their food selection, and especially as they mastered fire, the texture of the menu changed abruptly. Fire did more than just soften food. It broke down plant cell walls and complex protein structures, releasing a massive amount of calories and nutrients that were previously inaccessible to the body. It was a revolution in ancient survival. Roasted tubers became soft. Cooked meat was easily torn and digested. The crushing pressure disappeared. This mechanical unloading, occurring over thousands of generations, freed the skull from the need to maintain a massive jaw system. It no longer had to serve as a sturdy anchor for dense muscle bundles. The result was a structural shift. The jawbone shrank, the chin became more defined, and the teeth narrowed in size. The facial structure was slowly refined, becoming more elegant and delicate, gradually shaping the face of modern humans. The impact of prehistoric food sources reached far beyond the structure of the facial bones. The abundance and diversity of this flexible diet profoundly influenced human development across the entire body. A steady supply of animal proteins, fats, and plant-based micronutrients directly determined maximum height. It dictated bone density, creating stronger skeletons to withstand injuries. It shaped muscle endurance for long-distance hunts. More importantly, it determined survival. Infant survival rates increased significantly when mothers were provided with sufficient energy. Women's ability to recover after the physical toll of childbirth also improved. Conversely, a community facing chronic famine would leave its mark on the skeletons of many generations. Shorter stature and more fragile bones. Natural selection took place right at the dining table. These are not abstract numbers. They are concrete evolutionary advantages measured in lives. The environment does not simply set out a banquet. Over many generations, that very banquet has molded the shape and strength of humanity. The act of foraging in the wild is far more complex than the instinctive hunting trips of other animal species. For our ancestors, the first Homo sapiens, the efficient exploitation of diverse energy sources required more than just physical strength. It demanded an explosion in cognitive capacity. Especially spatial memory. In the struggle for ancient survival, their brains had to function like a sophisticated biological navigation system, continuously recording and updating thousands of ecological coordinates. These were coordinates of life and death, stretching across vast, volatile territories. This brain did not store paths. It stored opportunities and threats. These ancient humans carried a living map in their minds, a three-dimensional map drawn by experience and paid for with sweat and sometimes blood. They had to remember exactly which rock had water trickling from it at the height of the dry season. They had to mark which bend in the river frequently saw the carcasses of large animals wash up after floods. They had to calculate which valley would burst with berries as soon as the frost season ended and how long that window would last. Most importantly, they had to etch into their minds which forests held dangerous predators that must be avoided at all costs. These were not choices. These were survival mandates. Forgetting the location of a water source meant death by thirst. Misremembering the timing of ripening fruit meant a futile trip that wasted precious energy. Stumbling into the territory of a carnivore was an unappealable death sentence. The loss of these spatial memories meant pushing the entire tribe towards starvation or becoming prey. The primitive human's food source was tethered to every inch of ground they traversed. This complex information system could not exist solely within the mind of a single individual. It was too risky. It had to be shared to optimize the survival of the group. Food, therefore, became the most powerful catalyst for the evolution of communication and language, a turning point in human evolutionary history. Long before humans used language to tell stories about gods or craft myths, the first sounds and gestures were born to serve sharp commands, commands that decided survival. A short, repeated howl was not for singing, but to warn of a newly discovered toxic plant. A series of decisive hand gestures was not for dancing, but to indicate the direction to a water source hidden behind a mountain range. A rhythmic sequence of deep and high sounds was not to create music, but to organize a siege formation and provide cover while hunting large, dangerous prey. Human development was shaped by these rudimentary interactions. By sharing the location of a fruit-laden tree or demonstrating how to process a toxic tuber, Homo sapiens established the first social learning network. Food forced them to look into each other's eyes, coordinate, and pass down experience from one generation to the next. A piece of meat might fill the stomach for a moment. But the communication about how and where that piece of meat was found was the invisible thread, creating the increasingly solid social structure of humanity. The fatal weakness of any specialized organism is confinement. They are tethered to the very territory that holds their sole food source. A primate that eats only the leaves of one specific tree will forever be unable to cross a mountain range where that tree does not grow. For them, the boundaries of their menu are the boundaries of their world. Homo sapiens, thanks to an incredibly flexible diet, unshackled themselves from those chains. When the climate changed, forcing them to leave their familiar lands, they did not need to bring their old ecosystem with them. Instead, they carried their power of observation, their experimentation skills, and a brain ready to learn. An omnivorous diet turned them into unparalleled nomads, capable of walking from the African savanna across barren deserts to the icy regions of the north. Each new land was a new survival puzzle. Facing plants they had never seen and animals with unfamiliar behaviors, they restarted the process. They used accumulated experience to cautiously test tubers and berries. They analyzed the tracks of strange prey and looked for patterns in water sources within canyons they had never traversed. Step by step, they rewrote an encyclopedia of survival for that specific region. The ability to crack bones to extract marrow shows that our ancestors knew how to utilize what was left behind. But it was their capacity to eat flexibly whatever they found along the way that provides the greatest explanation for human expansion, shaping the entire history of human evolution. They dominated the planet not because they found a promised land with perfect food, but because they possessed the ability to turn any hostile environment into a problem that their intelligence and their stomachs could solve. Next time you sit down to a meal, remember that it is not just a necessity. It is the legacy of millions of years of harsh evolution. But adapting to a menu was only the first step. The true journey began when Homo sapiens left Africa. In Episode 3, we will follow them on the greatest migration in history, facing deadly climates and, for the first time, encountering another human species, the Neanderthals.